In the final question that we looked at on the last page, we had an equation with an x and a y variable that had an infinite number of solutions. Here's another example of an equation that will have an infinite number of solutions. If y is equal to 5, then x could be 3. If y was 1, then x could be 7. If y was minus 2, then x could be 10. If y was a half, then x could be 1.5. No matter what we choose y to be, there's always going to be an x value that we can choose to make our equation equal to 8. Here's a bit of a visual representation or an analogy to help you understand the infinite number of solutions in this equation. So if we represent this equation by a dot on the page, this is our equation, y plus x. And we can come up with one solution for this equation. And we can represent that solution by a line. So let's say this solution represents y equal to 2 and x equal to 6. I could draw another line through this dot, and let's say that represents the solution y was equal to 1 and x is equal to 7. I could draw another line through the solution, through the dot. Let's say that this is y equals 0 and x equals 8. And I could draw another line, and each of these lines could represent a possible solution. They all pass through the dot because they're all a solution to this dot or to this equation. And I can keep drawing lines and keep drawing lines, and I could keep coming up with more and more and more solutions like we did here. And so when we have one equation with two variables, we can come up with an infinite number of solutions to that equation. We can draw an infinite number of lines through our dot. Now, if we want a specific solution to our equation or a unique solution, we need some more information. And what we need is we actually need another equation. So let's consider the equation x minus y equals 4. This is another equation, a separate equation. And we can represent that with another dot. Now we have two equations. And I want one solution that works for both of these equations. One line that passes through both dots. We can get rid of all of these lines. And now we can only draw one possible line that passes through both dots. One combination of x equals something and y equals something that makes both of these equations true. There were an infinite number of solutions to this equation, and there's an infinite number of solutions to this equation, but there's only one solution, one x and y value that will make both of these equations true at the same time. Now that x and y solution is x equals 6 and y equals 2. Not x equals 6 and y. Oh, yep, x equals 6 and y equals 2. So if x is 6 and y is 2, 6 plus 2 is 8. If x is 6 and y is 2, 6 minus 2 equals 4. This is the only solution for x and y that will work for both of these equations at the same time or simultaneously. So to find one unique solution, we need two equations if we have two variables. The same thing applies if we have 3 variables, we need 3 equations, and 4 variables, 4 equations, 5 variables, we need 5 equations. But we're just going to stick to 2 variables and 2 equations that we solve simultaneously. We find a solution that works for both of those equations.